This video is brought to you by Sporlan, quality, integrity, and tradition. This morning we have a kitchen AC, the back kitchen. So this is their office and the back prep area. And they say that it's not working properly. So this is a York Predator unit. Nothing too crazy. So let's open up the electrical section. So these guys do have logic, and we can look in here. And if you look in here, we've got an error message. So let's count them. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, so 7. So if you come down here, 7 flashes. If you come down here, compressor lockout, FS1. So we need to dive into this guy. So it's definitely off on lock. So I always just do a visual. First off, that condenser fan blade is free spinning. Let's go right here. Let's see if this guy moves. That one moves. Doesn't necessarily mean it's not bad, but we're just kind of visually checking out the unit. Now we don't have the disconnect switch turned off, but definitely have an extremely loose belt, extremely loose. So that's a problem. Maybe some signs of oil on this TXV right here. What the heck is going on here? There's like a bolt laying in the bottom of the unit. That should be the tension bolt, so I don't understand what's up here. That should be going right here, unless someone took it out for some reason. Okay. Well, right now, we need to go ahead and reset this guy. We'll go ahead and probe up on it, and we can see what's going on with it. So down here, it says 7 flashes, FS1 compressor lockout. If you go up here, to right here at the top where the legend at, it tells you FS1 and 2, thermostat low evap temp. Okay, so what would cause a low evap temp, just looking at this unit right now, would be this extremely loose belt. That would definitely cause a low evap temp. So honestly, there's no point in putting probes on this guy yet. Let's go ahead and tighten up that belt, and then we'll finish further troubleshoot the. So on these guys, what we're doing is we took that bolt and we threaded it right back in. It fit right in there. Makes me wonder if this unit's vibrating to all heck, because why would that thing be out? So we loosen these guys right here on each side up, and then we can use that guy and that guy to evenly put tension. But we're gonna go ahead and change this belt. What you'll find is if the belts run really loose for a long time, number one, they wear out the adjustable sheave or motor pulley, and then they also damage the belts. So we've got a new belt, or somewhat new belt, sitting in here as a spare that we probably left last time. So we'll pull this guy off, put the spare in there. So while we're doing this, we're tightening up this belt. It actually just shut off, but I could hear that this one right here has a bad condenser fan motor, or something's going on, because the condenser fan motor wasn't operating. It's locked up. I could hear it trying to start from over there. And I just quickly opened up this door, and this one also has a loose belt. This is their other kitchen AC. So we'll definitely bring this up to the customer. We need them to generate a work order before we can work on this unit. So I'll go talk to them and have them generate a work order for that one too. But we'll get back onto this one. So we got the belt tensioned up. We're gonna go ahead and probe up on the unit and just diagnose both circuits, make sure everything's working properly. All right, I'm gonna attempt to profile measure quick here, and let's see if I fail at this again, because I've been having a heck of a time. So I've got a 2-stage compressor, 2 separate stages. They're not parallel. Okay, so we're gonna go down here, multi-circuit or multi-stage. Now apparently they call multi-stage 1 compressor, 1 set of probes, multiple equipment stages. This is where I don't understand. I would call it multi-stage. So if we click on multi-stage, number of stages, 2 stages. Okay, so stage 1, switch. Please, anytime the circuit is switched in the app, your electrical measurements will be cleared out. That's fine. Okay, stage 1, stage 2. This is where I get really confused on this, but regardless, we're gonna go into system info and number of stages 2. It does not have variable airflow. Nominal tonnage is 90,000 BTUs. It's a 7.5 ton. 410A, 13 to 16 SEER metering device is a TXV. All right, so that's that, and I think we're good to go on this guy. It is not scroll compressors. I don't think that's gonna make a huge difference, but we're gonna say reciprocating, and then we hit continue. All right, now we need to go in, and I've already assigned my normal probe, so we'll put that on the first stage, and then we'll grab the other probes and put it on the second stage, and we'll see what happens. All right, we've got low pressure, high pressure, suction line temp clamp, discharge line temp clamp. Then we come in here, we have liquid line temp clamp. There is no liquid pressure port, so therefore our subcooling number is going to be a little skewed, and it's going to be rather high because there is going to be a pressure drop. If we come over here, when we're putting air probes on these units, I highly suggest if possible, you actually place them in there. And another thing is this unit does have an economizer, so we need to make sure that it is not opening up when we're trying to service this unit. So you do have your setting right here. Let me grab a pocket screwdriver, and we'll go right here to the minimum position, because if the unit's working right, when you power it down, that economizer damper should shut. So we're gonna turn and see how far it goes. Okay, it's already turned all the way closed. So this guy is shut 100%. So what I would suggest is that if you place your air probe up in here, you're gonna get a lot of mixing. Even though this is closed, it's still gonna be grabbing the outside air temperature, and it's not gonna be as accurate. So what we could do is when we're working on the first stage, you put the air probe down here. When you're working on the second stage, get a mixture of the two airs, because this side is gonna tend to have a higher temperature just because of the cavity and the dampers. Personally, the supply air probe, in my opinion, is fine right there, but the return is the one you wanna get inside just from experience. So we'll put this panel up with like 1 or 2 screws, and then move on to the second stage now. I mean, it's got a slight vibration to it, but nothing that would concern me, really. That seems normal, so okay. All right, we're gonna close this guy up and wait for the compressors to turn on. Probably gonna jump them out to make it go faster. Or I know the thermostat's calling, so yeah, we should be okay. We'll give it a minute. It's in a delay right now, it should be. All right, this compressor sounds like junk. It's really loud, but I am so confused on this MEASUREQUICK thing, because this is not really working. If we come over here and we look at this, when I switch between first and second stage, it's not switching the probes because the pressures are identical. So yeah, again, this is not the right mode. I'm so confused. So 1 set of probes, multiple equipment stages, 1 compressor. Yeah, no. So we go here and we do a number of circuits, 2. So now it actually switches the pressures, but it's really weird. I don't understand. Regardless, number of circuits, let's go through. Additional nominal tons. Yeah, we got to redo this. 90,000 BTUs. Expansion valve. TXV. The rest of that is okay. Compressor type reciprocating. Okay, so we're back into here. First stage. I mean, we're just letting it stabilize. Everything's looking a little weird at the moment because it just turned on. But yeah, that multi-circuit, multi-stage thing is really confusing to me. All right, this guy has been running for a few minutes. Circuit 1. I mean, nothing's too crazy. Subcooling would tend to be high. Usually see 15 to 16 degrees because it's using discharge pressure. Going through here, I mean, everything's looking okay. Nothing crazy. Airflow is a little funky looking, but that's not too crazy. All right. I mean, nothing like insane. I mean, you know, it's not perfect, but nothing insane. Right outside of the mark on suction. Let's go to circuit 2. Circuit 2, is running really low superheat, but subcooling's kind of in line. I mean, it's a little bit low, but that could also be affecting by the low superheat. What could be causing that low superheat is the question. What we actually need to do, the temperature split is not bad on the unit. Airflow is not bad. I mean, the unit's working. So what I think we need to do is we need to investigate the sensing bulbs on the TXVs, because that really low superheat kind of makes me wonder if we have an issue there. So I'm going to power down the unit. We're going to open this guy up and we're going to investigate the sensing bulbs and how they're strapped and where they're strapped. So where are they going? They're not down there. Oh, sensing bulbs are going through into this section in here. So they are where? They should be up in here. Right in here somewhere. Oh yeah, let's see. Oh, yeah, it feels like the sensing bulb's loose by moving it with my hand. So let me get in here, get this insulation off, and then we'll get a look at it. So I got up here to the sensing bulb. I had to pop the top on the unit a little bit, propped it up with a cinder block, but it's loose, but I mean, it's not horrible, but it could still use some love. It has a single strap and then 2 zip ties, which isn't the end of the world. The single strap should hold a bulb that small. It's just a 2-inch bulb. But we're gonna do some work to secure this a little bit better, clean up the lines. You gotta be careful because sometimes like it's kind of on a bend right there and maybe it's not making good connection. All right, we ended up getting double straps on each one. They're super tight and they're in good places. We're gonna still insulate them. This one I think can go just a little bit tighter. But the important thing was we cleaned off all the old insulation. You can see we sanded it all up. So now we need to insulate them, but one of the downsides to the way they design this is your discharge line. This is gonna be damn near 200 degrees in the middle of the summer. And you know, that foam insulation is gonna have a hard time, you know, keeping that heat from infiltrating that, which is kind of a bummer, but we'll do our best. All right, we got this guy insulated, strapped up. We also insulated the discharge line right in that area to try to dissipate some of the heat. I don't think this is our only problem. This one was a little loose, but it wasn't that loose. So I don't know if this is gonna solve our problem or if we're gonna have more stuff going on. But we're gonna start with this, put the top back on, turn the unit on, and evaluate it from there. So I powered the unit back on, but I had to reset the MEASUREQUICK stuff. So as I'm going through here, what I'm noticing is you've got to switch the circuits when you're profiling it, but it doesn't give you the active, like, so you could say 3.5 ton or 4 ton, but I have a 7.5 ton unit. So I'm just gonna go 4 ton and see what happens. I mean, yeah, it's a little different, but okay. So I think that's it. TXV, continue. Circuit 1, circuit 2. Okay, there we go on that. And then we're just waiting for it to power up. It's going through its delay right now at the moment. So, gosh, that compressor is loud, man. You're gonna have to warn them about that guy. All right, circuit 1 is looking pretty good. Superheat's ranging. It's moving back and forth, okay, but it's adjusting like it should be. Circuit 2 is doing the same thing. It's much better than it was. So we're gonna let it stabilize out and run a little bit longer. The airflow is still really wonky on this guy. And again, it could just be my ignorance, but that, let's see, what should we be running on a 7.5 ton? So 2, 24, 28. Oh, I guess we're right on the money. Yeah, we're right on the money now. But it's weird though, because when you change from stages, the airflow goes wonky. Boom. It's kind of odd, but whatever. But the temp split, again, we're gonna let it stabilize some more, but it's looking pretty darn good now. All right, I'm happy with this guy. First stage is looking pretty darn good. Second stage, looking pretty darn good. That's what I expect to see. So what we are gonna do is we are going to just kind of warn them that that compressor sounds like junk. We are gonna get another belt because we took the spare belt, so we're gonna get a one to replace that and put it in there. But other than that, this unit's good. I'm gonna go ahead and take my probes off of this one. Tell them they should have had me do a regular PM and they could have saved a service call fee. But it is what it is, right? They did give me a work order for that one, so we're gonna jump on that one and see if there's any issues. And then at the same time, I talked to management And we're running around checking belts on all their units, because if this one has a loose belt and this one has a loose belt, the odds are all their other units have them too. So we're gonna check on those. That way when we go to get this extra belt, we'll pick up any other ones we need. All right, there's no need to check voltage at this guy because it's just locked up. The bearings are bad. Can't even turn the dang thing, it's like stuck. So we pulled the side off. We're gonna pull that motor out, swap it out. We got a brand new one right here. We just went to the York distributor. So we got that. We got a new capacitor too. All right, this guy needs a capacitor because we changed the capacitor with the motor. But the problem is I don't know which capacitor is which. So you got one on the top, you got one on the bottom. So we got an easy solution for this. Power's turned off, and we're gonna ground out the brown wire to the capacitor, okay? So basically, I'm gonna have someone over here, they're gonna ground it out, and I'm gonna test tone right here at my meter, okay? So, let's see what happens. Okay, we have direct short to ground. Go ahead and take it off. Put it on. Okay, now put it on the other capacitor. Leave the ground there. Nothing, okay? So, which one was it? Okay, so it was the top capacitor. So now we know which capacitor to change, and all we were doing was toning it out by making a direct short on this line right here, okay? So it's this capacitor right here that I'm gonna replace. So we've got this motor replaced, reinstalled, capacitor changed, wired in. This one's good. We're setting up our probes for MEASUREQUICK. We just tightened up this belt just a little bit more because it was, yeah, that's much better. It was still a little loose, so we tightened that up. We also have a spare for this one now, so we'll leave that in there. We're gonna probe up with liquid line temperature clamps since we've got the panel open, then we'll close it up and then we'll probe up on the compressors. All right, for this unit, we actually got the spot over in the shade. I can set it up in landscape mode, and we're looking at this guy. So circuit 1, I mean, we're not looking horrible. The subcooling's just a hair on the low side. Now remember, 10 degrees seems perfect, but we're using discharge pressure, so we usually see 15 to 16 degrees of subcooling. But I don't know, this guy, I mean, everything else seems to be working okay. Expansion valve is opening and closing because we're seeing that number kind of fluctuate, which is pretty normal, okay? So let's scroll over. I mean, this guy might be a hair low on refrigerant. It's hard to say. We really don't have a load. The return air temp is 72 degrees. Temperature splits right where it needs to be. Airflow seems kind of decent. Delivered capacity is a hair on the low side. Oh, no. See, this is what I don't understand on MEASUREQUICK. It's confusing. When you go to circuit 2, it gives you a normalized target looking at both circuits. That's what's confusing about this to me, but whatever. So first stage I think is okay, but delivered capacity is just a hair on the low side. But let's go to circuit 2. Let's go back to, I mean, subcooling, that's what I'd expect it to be, about 16 degrees. Superheat's moving around. I'm very reluctant to put gas in this guy because it's a micro channel, and those are really tricky to charge in the field. I don't know. Let's go back to circuit 2 and look again. I mean, 12 degrees subcooling. I think I'm gonna leave this guy alone. This guy seems like it's working. Condenser fan motor's working now. Customer's not complaining. We actually found this unit while we were up here. So I'm probably gonna let this one go and then just tell them to keep an eye on it. Now, we have had a history with this one. If you may remember 20, 30 videos back, maybe 40, I don't know. A lot of videos back, we had to cut this ductwork out. We had to open up the side of the unit and repair a crap ton of leaks in that evaporator. But I mean, it's questionable whether or not it's short. It's right there. So I'm gonna leave this one alone, and yeah, and see this superheat's ranging too. See how it's coming down. That's normal for it to fluctuate. But all right, yeah, we're gonna give this one a clean bill of health and wrap this up. I can't stress this enough, and I keep bringing it up, and that technology is amazing, but we have to know how to do the work that the technology does for us. We have to understand how the technology is getting to, you know, the results that it's giving us, because it's very easy. Like I showed my ignorance in here, right? I'm confused. I don't understand, the exact protocols for profiling multi-stage, multi-circuit, whatever in MEASUREQUICK. And so I am, tripping over myself a little bit. Now, I think I've kind of figured it out. And the confusion, and I love MEASUREQUICK, but the confusion is the wording and the phrasing that they're using. Maybe I'm incorrect, maybe they're incorrect, maybe it's a mixture of both. It's hard to say. But we have to understand how to interpolate data and know when we're being led down the wrong direction. I can't stress that enough, okay? If we just simply hand a new technician all this technology and all these probes and they don't understand what's going on, something as simple as 15 to 16 degrees subcooling. Now, 15 to 16 degrees subcooling on a typical air conditioner is usually too high, but if you understand that we're getting discharge pressure, and sometimes there can be 30, 35, 40 psi pressure difference from the discharge pressure to the liquid pressure, and understanding if you don't have a discharge or a liquid pressure port, using discharge pressure to gain subcooling is going to give you a skewed number. And sometimes if you do the math looking at a pressure temperature chart, if you get 16 degrees subcooling, that could be actually 10 degrees subcooling if you were to get liquid pressure. So understanding that, because someone could be chasing a ghost trying to figure out, oh, it's overcharged, taking refrigerant out, and then all of a sudden the capacity goes down and, and they go down a vicious loop. So understanding how to take a step back approach and, know the basics, know what's going on and how to interpolate bad data. Right? Because it's very easy for us technicians to put the temperature probes on the wrong placement. What happens if, you're trying to get superheat and you put it on the discharge line, or, who knows, right? You could be led down a path that could be a problem. Okay. I mentioned I'm working on a package unit and using my supply air temperature, and I put it right in the side of the unit. Now I said, for me, this is the best place, but if we were checking the heating system, that would be a horrible place to put our probe. And we'd very likely melt our probe, okay? Because it's literally a half an inch when I shove it in that side panel from the heat exchanger. And that heat exchanger gets extremely hot, right? Now, even for cooling, sometimes sticking it in the side of the unit can be a problem, all right? If you're working on a train package unit, some of the old Voyager units, the evaporator's right there, and you're literally inches from the evaporator. That's not a good thing. You want to be out of line of sight of the evaporator. Now, in some situations, when you stick it in that side panel, you've got a blower motor and different things. Now, in a perfect world, we install the probes below the roof deck in the attic, but that's not always practical when you're doing package unit work, okay? So sometimes we have to make some decisions and do some things that aren't 100% correct, but we have to understand that there's going to be ramifications because of those shortcuts, and we have to know how to interpolate the data and, make sure that everything's going to be okay. So we really, really need a thorough understanding of the refrigeration cycle. And I can't stress enough, if you're a new apprentice and you're just getting thrown to the wolves, you just got out of school and they throw you in a van and are sending you out to service calls, they're doing you and themselves an injustice by not properly training you and giving you a proper apprenticeship, okay? So I went through a few things in this unit. I saw extremely low superheat. Now, on these York Predator units, it's actually very common to find loose sensing bulbs. And, I corrected that, right? I went ahead and went with a double strap. Even though I thought it was overkill, I double strapped it. We eliminated that problem, okay? It's also very easy. Experience helps with this, but I set a rule of thumb. Well, it's, very common to find loose sensing bulbs on these York Predator units. Now, I don't want everybody out there to just assume it's a loose sensing bulb every single time that they see low superheat, because then you could just be in a tunnel and not paying attention to everything else. But keep that in consideration, and evaluate everything. So I saw extremely low superheat. I corrected it by re-securing the sensing bulb and insulating it as best as possible. Sometimes, the unit's not designed the best. That discharge line should not be that close to that suction line. That's a horrible placement of it, and there's going to be ramifications. So I tried my best to insulate the discharge line. Again, there's not a
cookie cutter approach to everything that we do. We have to be able to adapt in the field. We have to be able to look at the system and say, okay, this is the problem, and in a perfect world, this is what I want to do, but I can't do that. So we have to make best with the tools and the equipment that we have and do our best to make it work, okay? It's not always perfect. It's just not always perfect, okay? But we try our best. Now, another thing I wanted to address is using your senses. I can't stress enough, when we are working on the rooftop, do not wear headphones. Do not play loud music, because you need to be able to hear everything around you. Now, I understand when you have to have headphones for hearing protection because you're working in a motor room, you want to protect your body. But when you're on a rooftop, I stress to everybody, don't put headphones on. I was on that rooftop and I heard a condenser fan motor across the roof. I could hear a noise and I said, I know that noise, that's not right. And I walked over there and I was able to get another service call. I generated more revenue for my company by simply being on the roof. I got more hours, therefore I made more time. I didn't have to bounce around to 5 different service calls. I was able to stay on one service call for the day, got my entire 8 hours that day, including, calculating drive time. That location's like an hour and a half away from my shop. So anyways, but I was able to spend an entire day, solve all the problems there, and now we don't have to go back. Okay. But again, because I was on the roof working on one unit, I'm listening. And then I'm going down and talking to management and saying, hey, we have 2 loose belts. I think it'd be very, very smart if you let us check all the other units so we can eliminate future service calls. And we did. We went up there. So we're using our mind. We're keeping the manager's best interest at heart, the restaurant's best interest. We're communicating with the manager. We're doing our best as technicians. We're also trying to take care of ourselves. It was a warm day. It was like 85, 90 degrees. So we're hydrating. We're going downstairs. We're taking breaks. We're, making sure we're eating lunch and all that stuff. But it's all about the big picture. It really is, and I can't stress that enough, okay? I really appreciate you guys making it to the end of the video. If you haven't already, please check out my website, hvacrvideos.com. We have merchandise available on there, these hats, these shirts. We have another shirt design, sweaters, beanies. It's a great way to support the channel. You'll be keeping my wife busy because she comes in here and does all the merch, packaging and ordering and delivering and all that stuff. So again, I really appreciate you. There's a couple different other ways you can support the channel. The easiest way is watch the videos from beginning to end without skipping through anything. And then there's links in the show notes of this video for other ways to monetarily support the channel through Patreon, PayPal, YouTube channel memberships, different ways. So check it out. I really appreciate you all, and we will catch you on the next one, okay?